Welcome to our first CETEC Lunch and Learn of the new environment. This Lunch and Learn today is going to be called 2020 View of Systems Integration, and it covers a clear view of systems integration. It'll be definitely lighting centric, but it'll also include some audio, some digital video, building systems, automation, and whatnot. So again, I appreciate everybody taking your time. Sorry for the false start there this morning. I was actually rambling on to myself for about a minute before I realized my microphone was muted. Today is actually moderated by Tyler Martin. Tyler's in Vancouver, and there is a Q&A section on the right-hand side of your screen if you're using the app or the mobile platform. You'll be able to type questions in the Q&A section, and Tyler will be answering your questions or caching them until the end of the presentation, where we'll bring them forward to the group. There will be a Q&A at the very end. That, all things being equal, this being our first virtual Lunch and Learn online, I'm sure I will talk very quickly, and I will try and slow myself down. The expectation is that we'll spend about 35 minutes today, and then have a Q&A at the end of the presentation. So assuming that Tyler gives me the high sign that I actually broadcasted that piece, we will continue.
Yep, you're all good.
Okay, thank you very much, Tyler. Okay, so let's get started here. A 2020 view of systems integration. And
you're muted again.
And I now see why it's muting. Okay, I won't do that again. An overview. What systems are we talking about when we talk about systems integration? We'll cover that. We'll be going through a few of the different systems. Again, we will be focused on some lighting and power distribution, but I am going to cover digital audio, video, IT networks, building management systems, and a few other things. What standards and protocols should we be looking for when we're talking about systems integration? We'll cover some of the standards and protocols that we talk about. Emergencies are real. Plan for them. Need I say more? We'll talk a little bit about that and how it affects our systems design when we look at integrated systems, as well as do networks really make things easier? So network make things easier, right? We'll be talking about network integration and our IT roles within our systems as we're going forward. And again, at the end, there will be a Q&A. Please submit your questions in the chat window. That should say live chat window on the right-hand side, and we'll have an opportunity to answer them. So kicking things off, what systems are we actually talking about? We're going to cover lighting, audio, some video, some IT networking, like I said, BAS, which is building automation systems. That has to do with everything from mechanical operations, security systems, plant services, and whatnot. That would be LMS systems, would be your lighting management systems throughout the building. Some buildings have a BAS or an LMS as a separate entity. HVAC system, which are usually included in the BAS, which stands for heating and ventilation systems. This has to do with airflow, heating and air conditioning, which again has a fair amount of tie-in to our integrated systems nowadays and how we look at that. And I'll talk about some of those items as we go. There's always the fire alarm. It's one of the most important pieces of any building integration, as well as backup and emergency sources. Without the lifeblood of emergency power and backup systems and our main power systems, none of our presentation or lighting systems actually go forward. There is always a kind of a design concept that people go forward when they're working on AV designs, lighting systems, or IT network designs, is they always seem to start what I believe to be kind of from the wrong end of the spectrum. They're looking at the presentation monitors, they're looking at video projection, the speakers that are hanging in the system, or the lights that are hanging up in the presentation environment. And unfortunately, it's great for a presentation outlook, but when you actually do systems design, it's super important that we look at it in a different order for making sure that we've got those integrations taken care of properly. So I would always propose that that this may be the correct order to look at your systems design. Start from the ground up. Start with your backup power and emergency sources, and obviously your normal sources. It's super important that we understand for emergency's sake, where our power sources are, how that power is being generated, and how it's being transferred to our required systems and also our normal systems. What happens when that normal power goes away, and what happens to our control surfaces, our control systems, audio distribution, video distribution, when there is no normal power available to us. The fire alarm systems and emergency public address would be the next thing that I would talk about. The first items of backup power and emergency sources are usually an automated transfer system. Again, we'll delve into that a little bit. But the fire alarm systems and emergency public address are subsystems that are triggered on their own, and we want to take notification for those. There's many applications where we would be pulling the fire alarm status or emergency public address requirements to bring down the background audio in a building, bring up the lighting for egress, to allow announcements to happen, or even in the visual environments, change our display screens to give visual notifications for the hearing impaired that there is an emergency state going on in our buildings. Lighting and emergency lighting systems. So again, being a lighting-centric company, I definitely will dig into this a little bit further. Please understand that the audible public address systems and emergency systems are just as important. But again, our lighting and emergency lighting systems design and integration are key to not only performance venues, but architectural environments, commercial lighting applications, even outdoor lighting applications for those emergency situations. So it's key to take note of those things. The next step I would look at would be our IT networking, and whether it's the integration networking of the AV system you're dealing with, or the lighting system, or the building IT infrastructure. It's important to have a discussion regardless of whether you plan on integrating with that in the first place. And we will talk a little bit more about networking as we go. Lighting management systems would be the next thing that I would talk about. Is there a master management system in a building that is dealing with it? Is there multiple lighting systems if ETC is not your complete system of choice? Is there other systems that we need to coordinate with? HVAC and ventilation systems, and this keeps coming in here. One of the things that probably gets forgotten in integrated systems is that we have multiple manufacturers or multiple subsystems in every room, and we can leverage some of the advantages that provides us, or even have some efficiencies when it comes to spending on equipment. So as a good example, most lighting systems in public spaces have some kind of either motion detectors or daylight harvesting that is related to the lighting control of the lighting. But at the same time, those input sources can be used as reference for the HVAC system, as a good example. If there's occupancy in a room, we can tell the HVAC systems that we need to turn on the air handling, whether it be cooling or heating. Whether the daylight is up or down, we can again give that information to the HVAC systems. Many of the ETC systems out there are not only lighting systems, but they're power control systems. We actually have the ability to do temperature control and other automations when it comes to that type of thing. BAS, or building automation systems, a master system for running your venue, your campus even, is the next discussion. And then we should never forget about our performance or presentation audio systems and video systems throughout the buildings. Everything that we do in a visual environment, whether it be lighting or our video projection or whatnot, they're all integrated regardless of what we're providing as our system. We want to take note of that. We want to work hard with our partners to make sure that everything gives the customers the best seamless experience they can. How's my speed there, Mr. Merton?
You are doing well.
Good. All right, everybody, we'll move on to the next slide here, and I'll use the down arrow instead of the pause button. So let's go through some of those items. Backup power and emergency sources. There's multiple ways of getting backup power or emergency sources for our mains power in any building. Most buildings nowadays have either a generator or a UPS backup. Generators were the standard for quite some time. With the development in battery technology inefficiencies in uninterruptible power supplies, UPSs have become quite prevalent in our installations. So you'll have many venues that actually may have both. They've got a large load generator for long runtime operation that is exterior to the building. They'll have an interior UPS battery backup system that allows for, we'll call it ride-through conditions, where it gives them 30 minutes of uptime. And there's quite possibly systems that have only one of those or a combination of both systems. One thing that some people forget to look at is that there is a few venues and definitely some campuses that have alternate sources of power, as in hydro, or the power generation plant that is supplying the campus or venue may actually have dual feeds into the building. And they're using one of those as their alternate source or emergency source, so that if they lose one, there's a redundant backup in the building. So always take note of that. Work with your engineers to have answer some of those questions and figure out where your power is coming from. It's important for this to maintain our systems, but it's also important to understand what we may be limited by once we move to emergency power. You'll be stuck with wattage limitations on your lighting systems or your sound systems. You may lose critical components when there is a transfer to a normal or from normal power to emergency. And power planning is key in any integrated system. The next piece is the fire alarm or emergency public address. And so I will deal with public address actually first here. Emergency public address systems usually are incorporated into your paging system within the building. So they've got a PA system, and there's quite possibly that it is required for life safety, where you're in a venue where that system is maintained under emergency situations, both power and signal, and is used for public address. Some systems have a fire alarm system with speakers built into it, where the fire alarm system is used as that emergency power, or sorry, that emergency public address system as well. The fire alarm systems are in every building that we touch, whether it's performance venues or commercial environments. It's important that whether we're required to by code or whether we're just want to pull that information, if you have the ability to, obviously if it's required by code, get tie-ins to the fire alarm system. And we'll cover that in one of our riser discussions a little further on. But even if it's not required, I do strongly suggest that if you're running an audio, video, or lighting system, that you get a dry closure from the FA at the head unit or multiple points along the way, so that you can use that information for when there is a fire alarm being triggered to be able to provide decision making within your control matrix. And again, we'll cover some of those items. I'm going to look at a little riser a little bit further on as we go through the presentation. How do we listen and talk to those devices? So redundant emergency systems need to be systems that are not reliant on processing. And so what that means is if you've got a Crestron processor, an audio DSP processor, even our lighting control processors, we want to make sure that the emergency lighting, in this case, or emergency PAs, are not reliant on something that's got a processor built in, especially because most of those systems do not have a life safety listing. And again, we'll cover some of that in a moment. They use a lot of just straight dry closures and relays to make things work. They have redundant power supply systems and listed ratings that we'll see in a bit. But again, most of the interfaces we have to the fire alarm system or the emergency power and UPS backup is a good old-fashioned system of dry contact relays and devices that do not require processing to function. In the event of interference, in the event of network failure, in the event of bad programming, we want those things to work and work every time. ETC provides dedicated relays in our systems throughout all of our power panels, throughout all of our dimming and control panels, as well as some of our smaller subsystems. They provide dedicated panic inputs to all of our devices that are listed, and we will be reviewing some of those listings in a moment, that allow that system to bypass any of its processing and function to bring power and lighting on in those situations. We also have the ability to give dry closure outputs out of most of those devices for downstream slaving, where we can pick up multiple devices downstream of our power panels and slave off of them. We rely on the triggers from others for the fire alarm notification or panic notification. And there's, again, many different ways of skinning a cat when it comes to this, but we always seem to be relying on the fire alarm system or the building emergency power system for giving us that notification. And one thing that is always true is that people are safer in the light. In an emergency situation, you can't go wrong by providing a considerable amount of lighting. Most of our emergency egress codes, whether it's our NFPA codes or our national electrical codes, they provide specifications for minimum lighting requirements or minimum power requirements. But the more light we can provide in an emergency egress scenario, the better, clearer, and that's a great word, let's go for the higher speech intelligibility the PA system has, the safer people will be in those applications. So let's look at lighting and emergency lighting and some of the standards and protocols that we're kind of talking about. So the emergency lighting world and normal lighting controls is a constellation of emergency standards. There is quite a number of them out there, whether it be anything from our life safety codes, which are NFPA 101 ratings, to some of our UL listings, UL 924, which is emergency lighting and power equipment codes, UL 1008, which is our remote transfer switch equipment, and again, the NFPA emergency and standby power systems requirements, and they all interact under the National Electrical Code. And again, we've referenced some of the American terminology here, but this all relates and is usually completely collated with the Canadian electrical codes for safety and listings. All of the UL standards are ULC standards as well. And by the way, they're constantly evolving. Things change quickly as the technology has gotten more prevalent in the lighting systems, and the complexity of the lighting systems and audio and video distribution systems has increased. So the standards are changing. They're doing a pretty good job of keeping up, but as technology changes, and so do the standards. The roles of some of these standards. So I'm going to cover just two of them, again, that have to do with mainly power distribution and transfer. And the first one is the UL 1008 transfer switch equipment. And this would be an ETC device called an ELTS2 or an SC 1008, which we'll see in a minute. UL 1008 specifies construction details and testing for a UL listed transfer switch that complies with the NFPA 110 in the National Electrical Code. It specifies fault current requirements and what has to be kept working after a fault. So it's important that the devices that are listed at 1008 not only are able to protect themselves during a fault, but they continue to run if there is any downstream faults that happen. UL 1008 also has a very stringent requirements dedicated by separate asynchronous power sources. So that means separate power sources that are not from the same supply with the large available fault currents. These apply even at the 20 amp level when switches are used on a branch circuit and not feeders. And that's a lot of garble there, but I think it'll make sense when we look at the riser in just a moment of how those transfer systems work and how those UL standards are applied. The second one that we're going to look at is UL 924, an emergency lighting and power equipment. Again, ETC is not only a lighting system, a lighting manufacturer, they are power systems manufacturer and controls. So UL 924 is applied to both our lighting environments, but also our power distribution environments as well. And UL 924 specifies the construction details of emergency exit signs and luminaires or fixtures, automatic load control relays, unit equipment or inverters. So it doesn't just apply to our lighting systems or our emergency power distribution. It does not have stringent test requirements of the UL 1008. It is still a very high standard, but again, the UL 1008 is mainly in the power stream, so those devices have a much higher test requirement to meet that standard. Does not UL 924 does not have a fault current requirements as well. Again, UL 924, as you're about to see, is actually designed to energize emergency circuits or luminaires, but not actually transfer circuits between your emergency source and your normal source. Again, it's about getting the things turned on and up and running, not necessarily transferring power, whereas UL 1008 is designed for transferring the upstream power or downstream power. So a lot of garble there again. Let's make it a little bit simpler for you. Let's talk about our offerings. ETC emergency offerings are the range of acronyms on the left here, and these are all devices. ETC is really good at putting acronyms to all of their devices, so we'll just talk about them really quickly. We have our Emergency Lighting Transfer System 2, or ELTS, which is not only used for lighting transfer, it's used for distributed circuit transfers, as well as our branch breaker alternate source transfer, which is an SC 1008. Those are both UL 1008 listed devices, and again, they're transferring power for downstream lighting loads or power loads, and they could be amplifier loads, they can be distributed video loads, they can be distributed power for devices as well. Sensor 3, Unison DR racks, Echo relay panels, Sensor IQ relay panels, or automated breaker panels. Echo room controllers, which is our smaller independent 4 and 8 circuit room controllers, as well as Foundry mini panels, are all UL 924 listed devices and have those panic inputs and the ability to trigger on in an emergency situation and meet those UL standards. The next 4 acronyms, or 3 acronyms, is EBDK and DEBC. One's our emergency bypass kit, which we'll see in a minute, which basically monitors normal power. The other one is our emergency DMX bypass controller as well. And then we also have an automatic load control relay, which is the ALCR. All of those, including our GDS fixtures with our emergency line, are all UL 924 listed devices as well. So again, very lighting centric here, but we use many of these relay panels for power distribution, and we want to ensure that that power is maintained at all times. Any of our individual zone controllers are not UL listed at this point. So we'll go through these really quickly. We have our ELTS2, which has been manufactured in UL 1008, listed for 20 years. It comes in a variety of 2 to 24 circuits. It can be either emergency mains fed, so that is a high current single phase or 3-phase power feed, or discrete fed. So if you've got an emergency breaker panel with individual feeds, this panel can be ordered as discretely fed. It's available in 120, 277 in a NEMA 1 or a NEMA 4 enclosure. It has a discrete fire alarm input for transferring. So again, fire alarm can be tied directly to this transfer device. The one note is that this panel needs to be ordered with the correct specifications in the first place. It is not upgradable in the field. And the reason for that is that the UL listing is at the manufacturer's facility and the panel requirements. So it has to be done by UL listed, our 1008 manufacturer, which is ETC in this case. Of note, the ELTS panel can be used, like I said, not just with the lighting system. It can be used for circuit power transfers in the field. It actually has discrete fusing involved for each of the sub-circuits that go out from the panel, as well as a time delay relay where the ELTS monitors the status of normal power. So when your normal power comes back on in a building, usually you get a little bit of a bump or maybe a delay. The power comes back on, the grid couldn't handle it, and it dumps out for a second. So the ELTS actually monitors power for up to 30 seconds. That time delay can be extended as well, and assuming that normal power is current and present and correct, it will then transfer the loads back to the normal power feeds. There is a requirement with the changing environments of lighting that ETC manufactured a single branch breaker emergency lighting transfer switch, or an alternate transfer switch. This is the same as the other box. It is has a time delay for returning back to normal power. The sense and normal power feeds need to be from the same circuit. That's something that while you're doing your power planning with our engineers to talk about. Again, 120 or 277 volt, it has a fire alarm input. The difference is this panel has the ability to take lighting control signals for either 0 to 10 or DALI and have a cutout that happens with them. So if you had 0 to 10 controlled or DALI controlled fluorescent ballasts or LED fixtures, it's important that if those fixtures are being transferred to an alternate source, that the control line gets lifted so that the fixtures are told to go to full. Anybody that has wired up 0 to 10 or DALI, assuming that that loop or the 0 to 10 line is actually cut, then the fixture will actually go to a full intensity. So it's important that you use a proper device downstream to break that control line so that the fixtures not only are on an emergency power source, but they actually go to full. EBDK is our emergency bypass detection kit. It is a very simple box. It is a UL 924 listed device. This box actually gets used obviously a lot on our lighting systems, but it definitely gets used in power monitoring systems for integrated AV solutions or broadcast solutions. So the simplicity here is this box senses normal power, so you can feed it with either a single phase or a 3-phase power source. It monitors normal power. When normal power goes away, the listed circuits inside close a number of closures and distribute that. It actually provides contact closure routes to meet the UL 924 listed inputs for all the ETC devices, but can be used also on any other listed downstream devices. It has, I believe, 4 or 6, and Tyler will check that for the end here, separate outputs inside of it for multiple systems. So if we needed to take a closure to the lighting system or a closure to the Crestron system or closure over to the audio system, we can actually provide each of those discreetly. It also accepts the fire alarm input. So in our systems design, we'll actually take our fire alarm and tie it into the EBDK and then provide downstream switching from there. The breaker on the front is key lockable, and it maintains people's, keeps people's sticky fingers, as it may be, out of the system. That breaker is on the normal sense feed. It also provides you an opportunity to, with the proper key, to open the panel, flip the breaker, and do a test, which is hypercritical in power systems and emergency power systems. That proper testing happens on a regular basis. Talk a little bit more about emergency in a moment. One of the lighting specific devices that ETC makes that has to do with emergency has to do with the fixtures, mainly architectural fixtures that have come out over the last number of years. Fixtures have moved from being line dimmed fixtures to 0 to 10 control fluorescence, 3-wire fluorescent to our LED adoption. And the architectural control and commercial environments have also moved over to actually using DMX controls now. There is quite a considerable number of manufacturers that now manufacture and have adopted DMX as a lighting control protocol. This box is again a UL 924 listed box, and for simplicity's sake, it takes DMX incoming raw 5-pin RS485 DMX signal and has an internal transfer system. It needs to be powered by emergency power so that it is always maintained. And in the event of a normal power loss or a fire alarm fed from our EBDK system, this box will interrupt the incoming DMX and present an emergency look, which is either able to come from the factory as an all-on look or actually be field recordable. It also has the ability to act as a 1 or a 6 output, so we can split, again, at a listed device. This is a listed UL924 input box and opto output. It has a local test switch and an indication on the front of it as well that allows people to, or facility staff, which is a key component in this, a non-technical person to go around during their monthly inspections and go and test the emergency lighting system without having to touch the main controls or have knowledge of passwords and whatnot. So this device, as well as a couple of our others, also has the ability for remote testing. If you go back just a couple slides, our SC1008 actually has, because most of these would be installed in the ceiling, actually has a laser test input, so you can take a laser pointer with you. Because you can't climb up a ladder, you can actually shine a laser at it and it'll run a test and transfer the circuit for you. So we'll move forward. How we doing, Tyler? How's our time?
You got about 5 minutes to get through everything.
Okay, let's pick up the pace. All right, I'm going to jump over really quickly and look at a riser. So this here is our sample ETC control riser, and I just want to highlight a few items on it. So let's just talk about how that emergency EBDK works. So our EBDK would be positioned here. It would be fed with a sense feed from normal power. It would also take a fire alarm input into it, and then it provides what we call panic outputs to our listed devices. So you'll note here that we've taken it over to, in the case that we were just speaking of, the DMX DEBC controller. And this is providing a closure relay input. Our DMX source is coming from either one of our gateways or someone else's lighting system, and is allowing us to then transfer the DMX output to the downstream devices. We can control up to 192 devices through our 6 output device, or our 6 output model. We also provide that panic input to our 0 to 10 interfaces or your head-end control system. And again, whether this is a Crestron or an audio system, we want to take that panic input or that emergency trigger input into the main control processors to provide that information. When we talk about power switching in our top corner here, and hopefully you can see my pointer, our typical upstream power switching would be that we would have a relay panel or a dimming panel or a power distribution panel fed from normal power on the left. I'll just get rid of that for you. And some of the loads coming out of that will go out to your normal power and lighting loads. We would then take a selection of those circuits that are required to be on emergency and feed them through our ELTS emergency transfer panel over here on the right. It would be emergency fed or branch breaker fed, and again would take a panic input if required, and would automatically transfer. When the sense feed goes away, it will transfer to the power lighting loads. Most of our systems, as we get into integration, whether it be BACnet, our IT network systems, or AV systems, are going to integrate with our lighting systems via bidirectional Ethernet. They're going to be on a network. We're going to have communications back and forth, but again, depending on your system's design, we'll have gateways that allow us to do many, many different things. So we're going to go back to our presentation for a moment. Maybe I will have to speak quicker. Some of the protocols that we wanted to talk about today really quickly for everybody to understand is that we have DMX and RDM, which are a lighting protocol standard, which is basically RS485 distributed throughout your venue. We would be talking in our integrated systems, both 0 to 10 and DALI, which is a twisted pair conductor. It runs over usually some 16 gauge wires. And one of those is addressable. DALI can actually be an addressable system as well, power and data over the same set of wires. Unison echo wiring, or even BACnet twisted pair, BACnet being a building automation system, they all run a version of Echelon. And Echelon, again, is over a very simple 16 gauge twisted, basically speaker line that provides both data and power to it. Some other protocols when we're looking at our integrated systems would be ACN or streaming ACN for lighting. BACnet IP, which is an Ethernet protocol for the BASs to communicate with us, as well as UDP or TCP triggers. And in the AV integration world, serial is dead, and most devices get communicated with their master systems with UDP packet information, which is unsecured packet delivery, or TCP packet information, which is secured, and you basically get a response, secure response when you the receiving end gets the packet. Some of the other protocols when we talk about integrated systems would be Dante, or AVB or MADI, which are all digital audio protocols. There's a slew of more of them in there, and those are mainly Ethernet based or even just Cat5 based. And it's important when you're talking about integrated systems that if somebody says that it's a Cat5 system, that you clarify whether it's an actual Ethernet system that they're talking about, which is the protocol that our computers use to communicate TCP data and IP data, or whether it's just a Cat5 native system where the manufacturer has built their own standard of communication protocol that they're using just on simple Cat5 network cable. MIDI and SMPTE come in many different varieties of topologies and over different delivery mediums. But again, in themed environments where we're dealing with automation, where we're dealing with timing, MIDI and SMPTE and SMPTE timecode specifically are important for us to understand and how they integrate. Digital video, video over IP or HD-based T, again, varies on which protocol they're using. Some of these are over Ethernet data on true IP networks, and some of them again are using Cat5, Cat6 as dedicated topology or transport wiring, but again may not be compatible with our integrated systems. And then obviously fiber optic carries most of the protocols above. Almost everything above has some kind of converter to allow it to work over fiber. Fiber being used for our long distance and large bandwidths. The one major benefit that fiber has also, though, is that it is has very, very high resilience to RF interference. Fiber optic cable, being that they're a light medium transmission, can run large distances along power lines, along other RF transmitters, and not be affected. So something to think about when you're looking at your systems design. Someone may say fiber. Fiber has actually gotten quite economical, quite easy to terminate, and quite robust in use in AV integration systems or building or LMSs. Networking gateways. So ETC specifically and many other manufacturers make a variety of gateway devices, and a gateway is an IT term actually, and a gateway is a bridge between one topology and another, or one physical network and another. So ETC's gateways range from DMX and RDM gateways for lighting, 0 to 10 or DALI for architectural fixtures, SMPTE timecode for automation, MIDI, RS-232 to communicate with downstream serial devices, projectors, projectors and screen controls, as well as audio DSPs. They have dry closure ins and relay out gateways that will allow us to work with subsystems that are much simpler, analog controls and digital relay switching controls. All of our ETC control systems are native via Ethernet. We have a network backbone in our system. Everything is a network device. And we can operate open sound controls, BACnet twisted pair. I should actually say BACnet IP, I apologize. UDP or TCP data packets from automation. We can be bidirectional and proactive with AV systems. We can actually control projectors and DSPs all independently through our touchscreen controllers and our button stations on our native paradigm systems. We speak ACN and many, many other networking protocols owed over the wire. Networking makes it easy, right? Integrated systems design means proper network designs. It's super important when we're laying out any modern integrated system, specifically lighting system, that we're cognizant of what our network looks like and how it's going to integrate. Wired network systems are the norm in any integration. It's very common to get dedicated independent systems. They're more reliable that way. When lighting and audio are on separate systems, obviously there is some redundancy between the two, There's a reduction in bandwidth, security, building automation, as well as IT computers on their own subsystems, also lend to some more reliable features. That's not always the case. Sometimes we are required to work on the IT networks, and I invite everybody to learn how to do that, how to lay out systems. We can work hard with you to have a good understanding with your IT departments about what that looks like, and some of the pitfalls and some of the major benefits. And one of the major benefits that we have is that maintenance and security can be maintained by the IT department for sure. Once we all leave, usually we're going to be left with an IT group that is going to be managing our system in the future as well. Wireless systems, wireless for control and not for transport. Wireless should only be used, whether it's any radio frequency wireless, not only our Wi-Fi systems, but our dedicated wireless remotes, should only be used for remote control and monitoring. We don't want to transport critical data over wireless systems. Lighting levels, critical audio streams, or emergency visual notifications need to be done over a wired environment. It's super important for redundancy, as well as we have the ability to do real-time tasking where we can monitor the status of the endpoint devices and get secure delivery information that the devices are still there and functioning and that they did the action they were supposed to. And again, maintenance and security can also be maintained by our and managed by our IT for sure. So wireless systems for control, not for transport. IT departments are our allies. This is a big deal. For way too long, people were hesitant to engage an IT department because of their stringent security standards and policies. And definitely over the last number of years, both IT managers and the new generation of engineers have started to move us away from having dedicated networks for our subsystems and integrating onto the IT systems. IT and communications departments have been doing this for years. They've been doing networking long before any of our stuff had networking. IT probably has the infrastructure already in place. They probably already have the wires and switches and fiber in place. If that's the case, you should always ask to see if you can get dedicated hardware. Maybe they can provision and even provide the switches and fiber transmissions and dedicated hardware to live on their network. They're going to be more comfortable managing their hardware, and all we're looking for in many of these cases is transports. Mandate VLANs and explain why. If you educate your customer, you educate your allies with the IT department, and explain why you require VLANs and what you're doing, you're going to be in a much better place if you inform them now, together what you're working on to help them later. IT will probably need to service these systems once we're gone, and they'll have a bigger and better comfort level if they were the ones that actually deployed them in the first place. Engage the IT world and maybe offload some of the costs and heavy lifting to the IT departments. When you're talking about value engineering or even cost containment, especially in the world that's about to come to us, it's important that you engage the IT world. They're there, they already have the transport. We wouldn't put in our own power systems to the building for our lighting or audio systems, so why are we doing the IT? VLANs are a must, and that was a note just at the end of that last one. So here's a visual representation of VLANs, the master network sitting at the top of the screen, and dedicated, basically software isolated networks that are created for our lighting systems or our audio systems throughout the building. And it's important that we get VLANs where we can, and there is some white papers from ETC that explain our requirements in VLANs. ETC uses multicasting, which is a considerable bandwidth hog on networks, and IT guys, want to know that. 3 slides to go. Presentation, lighting, audio, and video. So we spent a lot of time talking about emergency systems and whatnot, and obviously with the state of the environment right now, that's definitely foremost on most people's brains, but always should be. It always should be. Digital audio and video protocols are continuing to evolve. They will be changing constantly and will need updating and management. They use lots of networking ports, so when you talk about AV systems, lighting systems, integration restaurant systems, they're basically everything is a network port hog, It has a network port on it and needs dedicated switches to populate all these networking devices. And they use even more addresses. There's so many devices that are actually consuming more IP addresses on a network than they are actual ports on the network. There's large bandwidth requirements with AV and lighting, where we're doing multicast traffic for audio and video as well as lighting interactions. And something to be cognizant of is that these VLANs that we're creating need to also allow us the communication or interaction between multiple systems, multiple venues in the same building. We may have 3 or 4 venues, 3 or 4 meeting rooms, 3 or 4 buildings on a campus, and or remote locations via the internet or via dedicated connections. So again, planning for those multiple systems is key, and the interactions between them. Planned routing in VLANs is a must to keep everybody in their own pool. We want to make sure that we do that. We want to work with our IT departments to make sure that we get that integration done. I'm going to skip the riser again to keep everybody on topic, and just jump down to the last couple of slides here. Device coordination schedules. So when you're planning an integrated system, there's a lot to the drawings and the risers that we showed earlier, but there's also a ton to maintaining data information in the back end. And whether it be an IP schedule that allows us to keep our devices listed, whether it be load information for what relay is running which power device, getting that data recorded into a coordination schedule, in this case an Excel spreadsheet, is key. And the more information, the better. I used to have a poster on my wall from the Toronto Construction Association, and it was a Rembrandt with a bunch of dogs playing cards, and it said, "Ye with the best paperwork wins." And it has to do with construction contracts, but at the same time, it has to do with successful integrated system solutions. People that have well-formed information, well-formed coordination schedules for both addresses and whatnot, allows you to share that information with your team as well as the IT teams that are out there. This is a sample schedule that we run internally for our lighting system specifically, that talks and covers IP schedules, serial numbers, panel locations, physical universes that we're talking to, and also helps us maintain software revision levels throughout the building and whatnot. Most of these schedules are all automated. We jump around them. It's super important that you get a good coordination schedule. Anybody would like some templates from us, we would be happy to share those with you guys to use in your own systems. All right, in wrapping, review and set your priorities. It's important to, when you're dealing with integrated systems, and again, this is not just a lighting thing. This is an audio system, subsystem, video, digital signage. Again, everything else that's up on the screen here. Review your priorities. Most of your systems design should be taken from the human approach. We should worry about life safety. We should worry about our user interfaces up front, and make sure that we do our touch panel layouts accordingly, and control surface layouts that's going to work for the people that are using the system or actually attending the venues. So set your priorities early. Worry about your power, fire alarm integration, emergency lighting. Again, everybody in the light wins. Your IT distribution, and then further down the chain after that. We're going to move to a Q&A session. If anybody has any questions, you should post them up for Tyler in the right-hand side here. We'll move on to there. And while I let Tyler kind of gather those things up, I'd like to thank everybody for coming to our first digital Lunch and Learn. We will be producing product-specific ones over the coming weeks. Tomorrow is, again, our studio information session for the ETC studio fixtures, and it'll be hosted by Michael Harris, as well as this Friday will be our Field Service Friday general Q&A. We're actually going to hold a town hall that allows technical engineering staff or even just end users to come on and engage in bidirectional conversation with our techs, so that we can help answer your questions or dismiss any mysteries that are out there in the integration industry. So at this point, Tyler, do you have any questions for us, maybe?
There were two statements. Color source spots and pars are also UL 924 listed as an emergency fixture. Aside from the GDS fixtures and the color source PARs, and spots, those are the only UL 924 rated fixtures ETC has right now. And the follow-up to the EBDK statement was the EBDK has 3 unique outputs that are individually driven relays, and identical products can be driven and daisy chained on the same output. So 3 echo relay panels can be daisy chained on one output. However, you would not be able to mix an echo relay panel and say a unison DRD on the same output. They need to be on their own unique output as well. And we don't have any open questions right now.
All right. Well, then, thank you again, everybody, for joining us today. See if I can get my screen back where it belongs. We look forward to having everybody come and join us again on one of our CETEC group virtual lunch and learns. Be safe, stay at home, stay isolated. The world will come back. Thank you.